Hi again. If you were watching my previous video, then you saw that I showed you how to create a basic machine learning experiment. And I had created an experiment that tried to predict the outcome of an animal who was brought into the SPCA, whether or not that animal would be adopted or if it might be transferred or returned to an owner, so which of multiple outcomes might occur. And I got pretty lousy accuracy. So I wanted to give you a few tips on how you might get better accuracy for your model so it can make more accurate predictions. And you know what? The most important thing you can do, and I will show you what I've done inside the model as well, but the most important thing you do is spend some time on the data. Realistically, executing the experiment is maybe 15 to 20% of the work. 80% of your work is going to be spent getting the data and getting the data into a format where it's conducive and helpful for the computer to try and make predictions. So the original data set I downloaded from the SPCA data, and this was real data that stored the way the SPCA actually stores it. We had the animal's ID, the name of the animal, when they were brought into the SPCA, what the outcome was, so this is what actually happened to these animals. I use this to train my data. Different subtypes, like maybe why something happened, whether the animal type, the gender, so was the animal neutered or spayed, was it a male or a female, their age, 1 year old, 3 weeks old, 1 month old, the breed of the animal, dog or cat, and the color. Now, I do actually have 2 cats, but I actually recently adopted from the SPCA. And as I look at this data, I think to myself, you know, I know there are some things that drastically influence. I will admit, I kind of wanted a kitten. So we were looking for younger cats. But you know what? When the data is stored as 1 year, 2 years, 3 weeks, as a human, I look at that and say, sure, so a 3 weeks is a younger cat and 1 year is an older cat. But how does a computer see 1 YEAR and 3 WEEKS? It doesn't understand those represent numeric values that it would show you older and younger cats. So it's not really understanding those are numeric values. So it can't determine if maybe when there's a higher value, the animal is less likely to be adopted. It sees those almost as categories. So the first thing I need to do is rework that column so it shows me a numeric value that represents how old the animal is. And that's going to help, I think, make a more accurate prediction, because I think, knowing animal adoption a bit myself, I think the age of the animal is going to be a factor. I bet young kittens get adopted a lot faster than 15-year-old cats. The other thing is, look at the gender. I do know that some people prefer to adopt an animal who's already neutered or spayed, and there might be people who are specifically looking for a male or a female. But the way the data is stored in this column, that's all jumbled into one category. It'd be probably more helpful to have one column which is gender and one column which tells me whether or not the animal's been neutered. The other thing I think is important is the dog and the cat. Even dog versus cats, there might be different patterns for dogs and cats in terms of who gets adopted. So one of the things I want to do is I want to actually run a separate experiment to make predictions for cats and have a different predictions for dogs, because it might be different factors that come into play. The other one that I know is a factor for me is whether the animal's a short hair or a long hair. I'm going to focus in on the cats because I am a cat person. I love dogs, but it doesn't work for me to have a dog at home. I do have cats, and I prefer having a short hair because they shed all over the place, and it's a lot easier to clean up after a short hair than a long-haired cat. So I prefer short hairs. So maybe a flag that tells me if it's short hair or not. And even the color, if you look at the way they provided the colors, black/red, orange tabby/white, well, if somebody's looking for a white cat, well, I can't really identify just by glancing at this column all the white cats. So it might be, well, maybe I want a flag that tells me, was the cat white? Was the cat brown? You could even search for slashes and see, was the cat multicolored? So what I did is I used an incredibly complex technology to do this. I did it in Excel. And basically, I wrote a bunch of formulas to search for different substrings and so on. And I updated the data. And I created a new column called gender just by extracting the string male or female from inside there. I just used a little formula. And for the age, I actually did a little clever little math here and managed to calculate their age in weeks. So if it was age in weeks, then they're 1 year old times 52, whereas if they're 3 weeks, I would say 3 times 1 week. So I did some little clever stuff in Excel to generate the number of weeks old the animal is. Then I also extracted whether they were a short hair or a long hair and created a flag, a 1 or a 0, based on short hair or long hair. And I also created flags to indicate if they were white, brown, blue, or black. So I think having these extra columns is going to make me able to make a more accurate prediction using my machine learning experiment. So this took me a fair bit of time. I did some mucking around in Excel. You can use other tools to go ahead and create these additional columns, whatever works for you. So I just used Excel because it was there and it was one of the easiest ways to do it. So what I did, I'm just going to minimize those, is I updated those and then I created this new model. So I uploaded this new data set, and I'll just zoom in a bit, and you will see there's my updated SPCA training data set. And I will just prove to you that it has those new columns by visualizing that data set. And you're going to see it has all these extra columns in it that weren't there before. So you're going to see there's my the actual gender, whether a flag that tells me whether or not the animal was neutered, how old they were, and then I have their actual age in weeks. So I have all these extra columns in it now, which I think are going to allow me to make a more accurate prediction. Now I do want to just take a minute and go down to the bottom part of the experiment, because you're going to notice when I get to a certain point, this experiment from this point on is identical to my original experiment. I went on, I split my data up, I used 80% of my data and used that to train my model. 20% of my data is being saved for testing. I have a trained model task. I selected a different algorithm this time, multi-class decision forest, because I thought that one, after looking at the Azure Machine Learning cheat sheet, it looked like it might be a more accurate model. So I chose a different model to do my analysis. And then I scored my model and evaluated. And we'll check out the results at the end, but I just wanted to point out this part is identical. But I did add a few extra tasks at the top. So let me explain what those are doing, because these can be useful in addition to adding new columns and working with up your original data into a better format. There are some things you can do in Machine Learning Studio to improve your results and accuracy as well. I still had to select the columns that I wanted to use. There are some of these columns that I literally created just to help me do my calculations. I don't want the machine learning tool to start using those to factor in and figuring out the predictions. I want to be very specific about the columns I think are important. So I've selected the outcome type, what I'm trying to predict, whether the animal was a cat or dog, whether or not they've been neutered, which is my new column, gender, which is a new column I created, how old they are in weeks, that's another new column I created in my Excel spreadsheet, what breed they are, that was already there, short hair, that's another flag I created to tell me whether or not the animal is short hair or long hair, just by searching for the phrase short hair in the breed description. And I made flags to indicate if they had different colors, because I'm curious, maybe black cats are adopted more often than white cats, I don't know. Maybe when they shed the hair it shows more, I'm not sure. So I've selected columns, several of which of these are the ones I just created in my Excel spreadsheet. Then I did a split data, but what's a little weird about this one is I told you I think that there might be different patterns for predicting outcomes for dogs than cats. I think the factors might be different. So I actually would like to have one experiment to make predictions and one model to predict outcomes for cats and a different model for dogs. So how do I split my data up? You know what? I could have done it with Excel. I could have just filtered the spreadsheet and made one file for the cat data, one for the dog data. But I wanted to show you how you can actually do something like that right inside the tool. There's a couple of ways of doing it. The way I did it was with a split data, because that does just split data up. And what I did is, instead of just doing a split rows, which is what I did to say send 80% of the data one way, 20% the other, I said I want to use a regular expression, good old regular expressions, to indicate which records I want to go down path one. And my expression is, I said I want to look at the column animal type, and if it's equal to the word cat, I want it to go down path two. And what's neat is if you actually right click here after split data and visualize, and this is really useful when you start writing more complicated experiments, being able to sort of check the data after different stages. For example, here after select columns and data set, I can visualize the data, and you can see that the extra columns have been removed. So you can see you've successfully removed the columns you didn't want to include. And when you do something like a regular expression and you're not sure you got it right, you can actually visualize after that regular expression, and you can see that I have actually gotten rid of, if I select the cat column and go down, you can see all of my records are cats. This is where that histogram is such a great tool, so I can confirm that every record here is now a cat. So I'm actually only going to try and make a prediction specifically for cats. So that's what this split data does. It's a way of dividing my data up. Now, the other thing that happens frequently when you're working with real-world data is you run into missing values. You'll get a column that is blank or not applicable, so you do often get missing values. One of the ways you can handle that is you can use a clean missing data task. And basically what you can do is you say which columns you think might contain missing values. Now, typically I find these are usually the string values, things like names, outcomes, and so on. So you can name the columns you think have missing values, or if you know which ones do, or you can do something like say, hey, for all of the string columns that have missing values, replace it with, and I can scroll down a little bit here, a custom substitution value of unknown. So now anytime there's any column where there's a missing value, it's just going to put the word unknown, and I find that makes it a little bit easier when I'm analyzing the results. It makes it very clear which records were actually containing missing values. So cleaning up missing data is another thing that's a good habit to improve the results of your experiment. Now the other thing I wanted to do is when you import a CSV file, by default everything's treated as a string. But if we think about that age column, I want to make sure that my experiment knows that's a number, because to me I want it to interpret that as a number. So when it sees an age that indicates a 5 or 6 year old cat instead of a 2-week-old cat, I want it to really factor that in as the larger the value gets. Does that decrease the chance of adoption? I want it to think about that, not just is it a different value, does that change the chance of adoption? So one of the things I've done is an edit metadata task, and I've selected the column that needs to be changed, age in weeks, and I don't want it to be treated as a string, so I've said change that to a data type of integer. So this can be useful for date time values and for numeric values to make sure that they're being read as numbers and they're being read as dates and times. So that's a good one to play with as well. The next one's a little bit unusual. You may not have seen this before. It's a bit more of an advanced machine learning concept. It's the idea of normalizing your data. It's not crucial to do for this particular data set because I really only have one numeric value. But you may work with other data sets where you have a lot of different numeric values where this becomes important. Let's say you have a numeric value that ranges from 1 to 1,000,000 and another numeric value that ranges from 1 to 10. Sometimes the one with a wider range sort of dominates the formula, if you will. It becomes, because it's got such a wide range of values, it can skew the model. So what we do is we normalize all our numeric values and make them all values between 0 and 1 typically. So that way a number from 1 to 1,000,000, if you've got 500,000, is represented as 0.5. A value of 250,000 will be represented as 0.25. A value of 100,003 will be represented as 0.10003. And if you have numbers from 1 to 20, the number 10 will be represented as 0.5. The number 20 will be represented as a 1. So this is called normalizing the data. So getting all your numerical values to fall into ranges, so basically mathematically modifying them so they all fall in between 0 and 1. So the way you do that is you add a normalized data task and you say you want to use a min-max, and by default the min-max will actually convert the numeric values from a 0 to 1. And you can see for the columns, I simply said, if you go to the launch column selector here, you'll see I said any numeric column, I want it to be normalized. And that's a good idea to do for any data set that has numeric data in it, unless it's already been normalized for you. And then I ran my experiment. And let's take a look at the results after I did all this work on the data before running my experiment. So I have created some new columns. I have divided up the cats and the dogs. So this one's only analyzing the cats. I've handled missing values. I have made sure the numbers are treated as numbers. And I've made sure my numeric values are normalized. And the final results, well, the proof is in the pudding. If I look at these results, the last one I looked at, I had accuracy of about average accuracy of 35%. I'm up to 72%. And the last one, my average accuracy of about 78, I'm up to 89. And let's scroll down and see the actual predictions. So when my model predicted adoption, 81.2% of the time it was right. I'm still only getting 10.4% of the time I'm correct when I predict euthanasia, and only 7.1% right on return to owner. But if you look at transfers, that's up to 82.8%. So this is a much more accurate model. This is one I might actually use to truly try and predict outcomes for animals. There's still some room for improvement, but it's a big jump up from what I've done before. So maybe I should tweak the model some more. The other thing I might want to try doing is, if you do get digging further into it, on these individual models, there's actually some different parameters you can change that affect how in-depth an analysis it does when creating the models and so on. So changing some of these parameters might give me better accuracy as well. But hopefully that gives you a few ideas on how you can make your own models more accurate.